Unit 1, matter and measurement. So that, a lot of the information that is covered in Unit 1 is going to be review. You should have had a lot of this information before. A lot of you have. A lot of you might have even had it last year because you're sophomores and you've seen a lot of this information. There's nothing wrong with that. I think it's better for students to have seen some of the information that we cover at the beginning of the year so that you get comfortable with how I teach and what I emphasize. Okay? And I think that's what, Unit 0 teaches us a lot of things. Unit 1, a lot of it's review, but some of it might not be review. Some of it might be new. And that's okay. And so that you can get the information that you need, you can see how I teach it, you can see what I emphasize on, and therefore you can be successful as we move forward. One of the things that we do actually have a book for this class. On Monday, we will actually go through the whole setup process of that as we move forward. And then you would be able to get that book. If you don't want an e-book, you want a big, thick book that's heavier than you will ever need. I have those in my room. We can get those to you. Okay, so regardless, but there is kind of some things on this title slide that says that it is chapter 1 on there. So that's kind of what you'll see as we move forward. Whoa. Also in the notes, you will notice that in these slides that we have 1.1. That's where it comes, the section that it comes out of. I would say, hey, if I was a good teacher, or maybe I'm not a good teacher, who knows? I would say, hey, read chapter 1, section 1 for today. And knowing that I have a lot of, 15, 16, and 17-year-olds in my classroom, most of you would not read that. Some of you are like, I'd read it, Mr. Peterson. I'm glad. But however, I'm pretty sure most of you would not read it. Okay? But if you need to reference it, that's what that's for. It's for you to be able to know where in the book you will be able to supplement that information from. Okay? As we continue forward, there are, and sometimes I disagree with the way the book is written, and that's just my professional manners, and that it says that there's 5. I prefer 4, okay, areas of study within chemistry. The ones that we focus on are going to be more of a general one, okay? But the main parts, the main things of chemistry are your inorganic, that means everything but carbon-based compounds. Physical chemistry, which is more of your theoretical stuff. It usually deals with some water quality stuff sometimes. It can deal with gases, thermodynamics, as well. Organic is basically the one thing that most chemists do not like, and it is usually also something that med students also don't enjoy. Organic chemistry is everything that deals with carbon, and since we're carbon-based life forms, you get that, and that's where biochemistry comes in. Biochemistry is just that, biology and chemistry coming and smashing together to make it interesting. That's the only way I find biology interesting, is through biochemistry. It's the chemistry inside cells is another way of looking at it. All of you, those of you that are going on to bigger and better things, that are planning on going into, say, medical school, you will have to take organic. You will have to take biochemistry. You'll also have to take a number of other biologies as well, but you're going to have to take those classes. A lot of times they call organic chemistry a weeder class. It weeds the weak links out of the people. Okay, so those of you that are planning on going pre-med, organic chemistry is going to be the thing. And so that's going to be a little bit of a difficulty. It took me 2 years to figure it out. However, I had some issues that probably added to the why it took me 2 times, but we'll talk about that at later times. Within these areas, there are even subdivisions of them, such as a analytical chemist. An analytical chemist can be an inorganic chemist. It can be a physical chemist, or it can be an oxymoron, an organic analytical chemist, which would be very weird. Because a lot of times the joke is organic chemistry is just kind of slopping some things together and seeing what comes out. And the purpose, though, for this class is to give you a little bit of everything. We want to give you a little bit of all the different parts of it, not just focusing on one part, one or the other. So we're going to cover some more of that as we move forward. So why study chemistry? Some of you are probably saying because it's a state law that I have to take this class. Well, it is the central science. Ultimately, that's what we in chemistry look at. It is essential science. Because without chemistry, biology has a very difficult time explaining what they see. And there are times without chemistry, physics has some difficulties. Without chemistry, even geologists don't understand what's going on. And because all of our minerals that we have talked about in, say, 8th grade earth science, they all have a chemical compound to them. I took a class called Rocks and Minerals, and I enjoyed it greatly because we had to like memorize, not only just identify the minerals, but we actually even had to memorize the compounds, what the formula was for those minerals. And I found it extremely fun. Some of the geologists didn't, but we were all different. And so that's what it is because chemistry is the central science. It is going to offshoot everything. Like I said, it's very hard to talk about biology without talking about chemistry. Photosynthesis does not get explained properly without the chemistry that is present. DNA, deoxyribonucleic acids, okay, that essential compound to life, is actually just billions of atoms. And it's just carbon, nitrogen, oxygen, and hydrogen. And it's just how they're put together makes DNA and RNA and some of those other things that we come to know about it. So why study chemistry? It's essential science, not just because it's state law and that I have to take it. So let's begin talking about chemistry at its earliest points. And even the Greek, everyone says like, oh, we can trace our roots back to ancient Greece. Well, that's because those guys were really smart and they did a lot of thinking. If you got a lot, if you don't have a Netflix password in ancient Greek, now we've got Netflix passwords and Disney Plus and Amazon Prime, so we can just mindlessly binge watch shows. Well, Greeks didn't have that. They had to sit around and just sit outside and be like, that rock fell. I wonder why. Maybe if I go up there and kick that rock and we'll see if it moves again. Or why is it a clear day today? The wind's coming from that direction. Why is it cloudy today? And the wind was changed the direction, but yesterday it was coming from a different direction. Just observing their world around them allowed them to come up with a lot of these thoughts that they had. Some of them good, some of them bad. Alchemy is that beginning. Ancient Greece, we just kind of look at that as alchemy, as the earth, water, wind, fire, and obviously we know that there are more elements after that. But those are what it is. Anything that was solid was just considered earth because you dug it up. Water, liquids, gases were winds, and then fire was this other element, so to speak, that we have. And these alchemists eventually thought it was a good idea to try and turn lead into gold because that would be a powerful thing. It'd be the cash money that you're talking about. That's what you need. And that's what you're kind of looking at is why do they kind of get that famous turning lead into gold and the philosopher's stone, which wasn't a Harry Potter thing. It was actually an alchemy thing before it was a Harry Potter thing. And that was trying to get information and trying to get power became kind of some alchemy. And actually, it turned out alchemy was looked and disregarded as kind of more witchcraft because of what they did, and because it was really chemistry. And a lot of times people are like, oh, I love chemistry, it's like a magic show. Yes and no. There's explanations of the why it is. But they weren't able to turn lead into gold. Little did they know that they needed more time and a heck of a lot of electricity to turn mercury into gold, because that's actually done a thing. But it costs more than the gold that you're going to get. So alchemists were onto something, but they were not always completely there. Now, specifically, we're going to look at matter, and we study matter, its properties, and its behavior. And that's really what chemistry is. Okay? That's what we look at. That's what matter is. That's what chemistry does, is that chemistry studies matter, its properties, and its behavior. Because it's not just looking at this picture and you say, oh, look, there's some icebergs. There's more going on to that. The iceberg is made of water molecules that come together and form these very crazy, weird, intricate patterns on how they were formed, at what temperatures they were formed. And then as they heat up, they become more disorganized, as in becoming liquid water. And then when that liquid water gets increased to temperature, the water vapor becomes even more widely disorganized, and it becomes all random water gas. And this is where we get into this discussion of it's the science in chemistry that matters, not you. You might be made of matter, but you do not matter when it comes to science. Okay? And it's really bone crushing for a lot of students to find that out, and when it comes to a lot of sciences, you don't matter. You're made of matter, but you don't matter. Okay? But that's how we look at it in science, is that it's the science that matters, not you. So when we're going to study chemistry, we're going to study matter, properties, and behavior as we move forward. That's what matters. That's there. All right. So how do we define it? What is matter? Is anything that has mass and takes up space. Okay? And we can see from these pictures here that can vary widely. That matter, it can be an element, it can be molecules, it can be compounds, it can be mixtures of elements and compounds, which is very important because we need that, as we are that in itself, is that we are composed of matter, we have mass and take up space, and it's the mixture of elements and compounds that make us have certain things. And that's why it's very interesting to kind of look at, those parts of it. And that's why, like, some of these sciences, when you get really into them, can be very difficult at times, because they really dive into the kind of what's going on. And for me, I think this is what makes chemistry sometimes difficult, is because we're looking at these pictures here and we find that that's what we're going to use to represent atoms and compounds. That's hard to visualize sometimes. I think that's what makes chemistry difficult. It's not the fact that it's really hard concepts. I think it's because we're dealing with things that are so small we can't see them. And we're dealing with matter that is so small that we can't see it, and that's what makes it difficult. And that's what makes chemistry hard. And once we can get over that, we will find ourselves kind of seeing things different. We move forward, we see that these things can be done. So, open too many spots. How do we look at matter? There's three different ways in which we look at matter. The macroscopic, that we can see with the human eye, that's everything that we can see, whether or not we're wearing glasses. If we're wearing glasses, we're still able to see. But if I take my glasses off, I can't see. Well, yeah, that's true, but it's their aids or corrections are what your glasses are. The microscopic, that's kind of more of your biology stuff, your cells that you need to look at a microscope. But that microscope can vary widely as well. That can be from like just a 10x lens on a microscope to a scanning electron microscope, where you're looking at things that are a million times smaller than a meter, because that's what a micrometer is. It's like looking at your pencil lead, your mechanical pencil, and then clicking it out and looking at there and saying, okay, there are 100 markings from left to right from that pencil lead. And if you're dealing with it, say if you have a 0.5 millimeter pencil lead, there are 50 markings inside there. A millimeter is 1,000 times smaller, 1,000 times bigger than a micrometer. Micro is a very fancy thing. It's a looking U. I'll get into those later. But it's really small, but things look very massive. And a scanning electron microscope would allow you to see the peaks, valleys, bumps, ridges, and all the binary, basically the binary things that are done on like a Blu-ray. When you look at a Blu-ray or like a CD under a scanning electron microscope, it looks like it's like some weird Lego world that has been built. It's just peaks, valleys, and they're all based on like blocks and stuff. And then you get into the particulate level, and that's what we live in chemistry, is the particulate level. And what we have to do and how we have to think is different. Even when we go into the lab to try and mimic some of the things, what we end up doing in the lab is that we take the macroscopic level and try and make a connection to what's happening at the particulate level in the lab. And that's for the lab, and that's because it's happening at a billion and billions of times over that we're able to see it macroscopically and try to understand what's happening at the particulate level. And so that's where we get into the why is chemistry difficult, is because of the size aspect, is that we can't always truly see what's happening. We just have an idea of what's happening as we kind of go through this. And these are the things. And so can we see atoms? And somewhat now we can. We have gotten powerful enough microscopes or powerful enough machines that will get us close. We kind of just see like a fuzzy picture of it, not these wonderful details, models that we will use to help us represent and help us understand what this might look like and what this might actually go for.